Hello everyone, today we're going to talk about the trig parent graphs and we'll talk a little bit about their characteristics. We'll talk much more about this in class. Today I just want to give you some idea of what these trig parent graphs look like. Okay? The first one we'll talk about is sine. This is a sine graph. We should have studied it earlier in the year. You can see it looks like this, it wiggles. Some things that I want to point out. It starts at the origin, or it goes through the origin, so 0, 0. Now, we will always map out the important points. And for me, the important points are the maxes and the mins and the zeros. So, the way that I remember this is it starts at the origin and goes 0, 1, 0, negative 1, 0. And it counts about 1/2 pi, or pi over 2. So, pi over 2, pi, 3 pi over 2, 2 pi. Okay? The period is 2 pi because this took 2 pi and then it repeats. That's why back here, this is also 2 pi and then it repeats. Okay? Cosine looks very similar. It's still a wave. But instead of starting at 0, it starts at 1. Because it can't go up, it's got to go down. Pi over 2, pi, 3 pi over 2, 2 pi. So its period is still 2 pi because once it gets back up here, it would repeat. Same thing on the back side, it just goes like this. Now, what do you notice about the sine graph and the cosine graph? Well, they're symmetric. The cosine graph is even, meaning that the right side and the left side are the same. It's symmetric over the y-axis. Well, what does that mean? That means that if you have some cosine x over here and some cosine negative x over here, because it's symmetric, they're both at the same y value. So these two things are equal to each other. That's one of the negative angle identities. How about sine? Well, sine is odd, meaning it's symmetric about the origin. If I were to take this and rotate it 180 degrees, I would get this back. So let's talk about a sine of a positive and a sine of a negative. Let's talk about sine x up here and sine of negative x down here. They're at the same y value except that this one's positive and this one's negative. So the negative angle identity here is sine of x equals the opposite of sine of negative x. Okay? Again, to memorize the graphs, just remember the shape. 0, 1, 0, negative 1, 0. And then remember we count by pi over 2. Cosine, 1, 0, negative 1, 0, 1, and you count by pi over 2. And it's the same thing on the back side. You just repeat your pattern. Tangent's a little bit trickier. Remember, tangent is slope, and slope doesn't exist at 90 and at 270. So at pi over 2 and 3 pi over 2. That's why there are asymptotes here. At pi over 2 and 3 pi over 2. Same thing here. But since it's also slope, since tangent is slope, that means that at 0 and at 180, so at 0 and pi, it's flat. So it has a slope of 0 at 0. It has a slope of 1, 0 at pi, and at 2 pi, and at negative 1 pi, and at negative 2 pi. And the general shape is this. So this graph doesn't have a period of 2 pi. It only takes this long to repeat. Well, how far is it from negative pi over 2 to positive pi over 2? Its period is pi. We talked about that earlier. So memorize the general shape, the asymptotes, and the x-intercepts. Remember, the x-intercepts are at every pi, and the asymptotes are at every pi over 2. So the x-intercepts are at pi, and the asymptotes are at every pi over 2. And the way we write that is we say it's k pi, so every multiple of pi, and every multiple of pi over 2. Sorry. Pi over 2 plus k. That's how you write that one. Okay? Oh, is this one even or odd or neither? This one's odd, so if I were to rotate it, I'd get that. Because it's odd, that means that the tangent of the positive and the tangent of the negative are opposites of each other. Secant graph. So the secant graph is kind of hard to see if I just show you like this. So the secant graph starts at 0, 1, has an asymptote here at pi over 2, then down at negative 1, has an asymptote at 3 pi over 2, and then back up here at 1. So that's kind of a hard graph to imagine. The better way to think about it is think about, instead of thinking about secant, think about cosine. Because secant and cosine go together. What's the cosine graph look like? Well, it starts at 0, 1, goes here, and then here, and then here, and then here. So, the top of the cosine graph is the bottom of the secant graph. The bottom of the secant graph is the top of the, the bottom of the cosine graph is the top of the secant graph. And look, the asymptotes are every place where the cosine graph hits 0. Here's a better picture of it so it's easier to see. Since the green line is cosine, at the max and mins of cosine is where your secant's max and mins are, but they're the opposite. The cosine's max is the secant's min. The cosine's min is the secant's max. The cosine's x-intercept is the secant's asymptote. And if you think about it, it makes sense. When the cosine is equal to 0, then the secant would have to be equal to the reciprocal of that, which is 1 over 0, which you can't do. That's why there's an asymptote there. So I always think about what does the cosine graph look like, and then from the cosine graph, I can draw in the secant graph. And that's going to be very similar to the cosecant graph. Again, the cosecant graph, I'm not going to think about cosecant, I'm going to think about the sine graph. Well, the sine graph starts at 0, 0, and then it goes up to this here, pi over 2, 1, and then back down to pi, and then back down to negative 1 at 3 pi over 2, and then back up here to 2 pi. And it does the same thing on the left side. I'm only drawing one period. Well, what can you take from this? Where there's an x-intercept, this cosecant graph has an asymptote. The max of the sine is the min of the cosecant. I have an x-intercept, so that means that there's an asymptote here. The min of the sine is the max of the secant. Again, an x-intercept, so another asymptote. The period is still 2 pi, because sine is 2 pi, so cosecant is 2 pi. Here's a better drawing of that. Again, I'm going to draw the sine graph in, because it's easier to memorize. And every time that the sine had an x-intercept, I'm going to draw an asymptote. And every place that the sine had a max, I'm going to make it the min, the cosecant graph. Every place the sine had a min, I'm going to make it the max of the sine graph. And look at your pattern. It looks like they're not parabolas, but they look like them. They just repeat. Cotangent. Cotangent looks very similar to tangent. Remember, tangent had asymptotes at the pi over 2's. Had x-intercept here and went up. So that was tangent. Cotangent is just the opposite in every way here. So instead of having asymptotes at the pi over 2, it has asymptotes at the pi's. So 0 pi, 1 pi, 2 pi, negative 1 pi, negative 2 pi. Whereas the tangent had x-intercepts at every pi, this has intercepts at every pi over 2. So in other words, where there were asymptotes, there's now x-intercepts, and where there were x-intercepts, there's now asymptotes. The tangent graph went up, flat up. This one comes back down. So just take everything about the tangent graph and switch it around. The x-intercepts and the asymptotes switch, and the shape goes down instead of going up. Knowing these parent graphs makes life a lot easier, especially when we get into the next two sections.